Hi, welcome to a2zknowledge.com. So today we are going to discuss about Numpy, which is a library in Python in which we are going to discuss about percentile function. So percentile function is widely used in statistical programming and especially in data science. People a lot use this percentile part. So we are going to discuss about that. And if you want to get the complete NumPy videos, you can get that in the playlist link, and the playlist link is there in my description box of this video. Back to the video. You can see the question is I will give you list of age as a numbers ages, so you have to tell me 25 percentage of age group falls under what number, 50 percentage of age group falls under what number, 75 percentage of age group falls under what number, and 100% and so on. So now I'm just doing that with np, which is numpy dot percentile. A is your array and 25 is the percentage I want to find out. So you have 25, 50, 75 and 100%. When you run this code, you can see here. So we have 25 percentage of age group falls under the age below 12. That means 12, 9, 7 and 1. So whatever the numbers you get, try to do it and try to order it first, then start the calculation, which is an ascending order. And then 50 percentage of age group falls under 18. So you can see here 18 and then whatever the numbers are below, the number and the below. 34, okay. 75 percentage of age group falls under 34. So 34 and then below. And 100% is your maximum number in the list, which is 56, and below is 100%. Now we are going to discuss what is the calculation behind the scene. So we have a very simple calculation here to find out the percentile. The formula to find out the percentile is p divided by 100, which is n plus 1. Okay, this is the formula, but you don't want to worry about the formulas and all those stuff. So let's find out the 25 percentage of age group. Okay, now the p is nothing but the percentage what you want to find out, so which is 25 divided by 100. So n is the total number of elements in your array. So you have 13 actually. So 1 2 3 4 5 6 7 8 9 10 11 12 and 13, right? So 13 plus 1. So 13 plus 1, so that is equal to 25 by 100 of 14, and that is equal to 3.5. Okay, so this 3.5, it is not the round value. So when you get this as a round value, that denotes the actual position. So which means like you have the position and the value, right? Yeah, so 1 2 3 4 5 6, so this is the position, so the position of the elements in the array. So this 3.5 is not the actual value. So this is instead, when you get the when you are not getting the round value, right, then this is the position. So 3.5 means 3 and 4. So third position and fourth position means 3.5 means 3 and above, right? So we consider third position and fourth position. So what you have in third position is, so yes, so 1 2 3 9 and 12. Okay, back here. So this calculation is not yet completed. So 9 plus 12 divided by 2 equal to 10.5. So when you are not getting a round value here, then it is a position. Whatever the value you get here, which is not a round value, then this particular value denotes the position in your elements. Okay, so here, so when this is not a round value, which is third and fourth, is a position we have to consider because it's 3.5. So we consider 3 and 4 the positions. Now it comes 9 and 12 by 2, 10.5. Okay, what is this value then? This is exactly the value in your list. So what is the very closest value that you have in your list with respect to 10.5? The very closest value what we have for 10.5 is 12. Okay, and that is the reason why you get 12 here. Okay, now we can go for 50 percentage. That is it's a different scenario now. So 25 divided by 100, sorry, it's not 25, now it's 50, right? So 50 divided by 100 and n plus 1, which is 14, right? So this will give you 7. So that means the value, whatever it is there in the seventh position, directly you can consider that as an output. So you don't want to do one more calculation because this 7 is not a decimal or a float, it's a round value. So what is there in the seventh position? So 1 2 3 4 5 6 and 7, which is 18, and 18 and below is 50 percentage of age group. So we got 18, right? Now next we can consider 75. So 75 percentage. So 75 divided by 100 of 14. The output is 10.5. Right. So this 10.5, which is like kind of the position, right? The first calculation output is kind of an position. It's not, the position is 10.5, which is 11, sorry, 10 and 11. Okay, what is the elements it is there in 10 and 11? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 34 and 35, right? Okay. So 34 plus 35 divided by 2, which is equal to 34.5. Okay, so which is 34.5, the nearest value. So 34 and 35, they are like nearest value, right? So 34 is the output that which we are getting here, which is all about, it's a prediction, right? So you will be having some kind of a not exact data you will get. It's kind of an approximate, some up and downs will be there. So 34, so 34 and then the below ages or belongs to 75 percentage of age group. And you can repeat the same calculation for 100 also, but 100 is all about, we can even say like from the list itself, the maximum element and the below 56 and below is going to be the 100%, right? So what I want to tell you one thing is, in the very first calculation, the very first output of p by 100 n plus 1, if it is a round value, then you can consider the element in the position directly. But if this is not a round value, then you have to do a one more step here. So again, you have to consider the position of the 3 and 4, and then you have to do this calculation, and then whatever the number which you derive is the final value. So that is how it has to be. Okay. So thanks for watching A to Z knowledge.com. If you really like this video, subscribe my channel and forward this to your friends and colleagues. We provide videos in two languages, English and Tamil, and not only Python, and we have so many other tech videos. You can just have a look into it. So thanks for watching A to Z knowledge.com.